Hi all. Today there will be a second video dedicated to replacing an old lead-acid battery installed in a UPS. Instead, I plan to install a battery of lithium iron phosphate batteries with a capacity of 6 ampere hours. Battery protection will be provided by the BMS protection board. If you have not seen the first part, you can familiarize yourself with it by following the link in the scripture. In the previous video, I showed how to assemble only half of the battery. Today I will show you how to make it bigger, install a new battery in the UPS, and perform tests. To increase the capacity of the entire battery and the current supplied to the load, I will use two BMS boards. Both boards are connected to the UPS in parallel. The current supplied by the batteries to the load is summed up, therefore it will be about 30 amperes. The process of charging and discharging here will work exactly the same as with a single board. When the voltage reaches 14 volts, charging will turn off. And when it drops to 10.6, the uninterruptible power supply will turn off. If all batteries are charged to the same voltage, then it will not happen that one of the BMS boards will turn off before the other. In fact, the same thing happens if you take two ordinary batteries and connect them in parallel. Even if the batteries are different in capacity and one of them quickly discharges, the second will constantly charge it. It will be different if only one of the cans is discharged before the others. Then the board will turn off and all the load power will fall on the shoulders of the second board. This option is unlikely, but in principle, over time, when the batteries begin to degrade, this could happen. Well, if this happens in the first battery, then both boards will turn off before the uninterruptible power supply turns them off. In fact, there is nothing wrong with the fact that the boards will turn off earlier than without an interrupter. It's just that by design, UPS should manage the entire scheme. And of course, this will indicate that the characteristics of the batteries have begun to change. Therefore, there was a voltage imbalance in all banks. This can also happen during charging. If one of the batteries is charged more than the others, and the voltage reaches 3.65 volts, the BMS will turn off the entire battery. And if the same thing happens to the second battery, then UPS will set off an alarm. The fact is that when the BMS stops charging its batteries, it completely turns off its input. Current no longer flows into it, and UPS does not see it. It does not detect it. Without an interrupter, electronics feel like the battery just fell off. Therefore, the emergency notification is turned on. But when the electricity is turned off at home, and the load is connected to the batteries via UPS, the BMS will immediately start working, and the UPS will identify them. Here I connected the new battery assembly to the UPS, and will show what happens if you disconnect it. Now the UPS is connected to the grid, charging the batteries. There's a speaker indicator on the display. It is not crossed out. This indicates that audio alerts are enabled. When I disconnect the batteries, a loud beeping noise starts. To prevent the alarm from ringing constantly, you can turn it off. To do this, just hold down the first button. The speaker indicator has now changed and no alarm will now sound. But many uninterruptible power supply devices do not have the ability to turn off the alarm. Therefore, if you have a simple uninterruptible power supply and something is wrong with the batteries, then get ready for such an alarm. The final assembly of 8 batteries turned out like this. On the outside, in addition to the electrical tape, I glued tape. I also made things like this using it. While working, just in case, I also sealed the ends of the wires with tape to prevent short circuits as much as possible. To connect two batteries in parallel, I made these wires. The batteries will be connected on the right, and the uninterruptible power supply will be on the left. Naturally, the original cambric did not fit onto the left tip, since there are two wires there. Therefore, I had to use regular heat shrink tubing. Now you can carry out the tests, see how much load the battery can hold. And along the way, I will show you one feature that appeared when using this battery. I connected two multimeters. The first one will show the battery voltage. They are slightly discharged and therefore their voltage is only 13.7 volts. And the second one will show the current strength, coming from the battery assembly to UPS. This is a computer power supply. I will connect it to the output of the uninterruptible power supply. It will be the load. Behind the scenes, I connected an electronic load to the output of the power supply. I will use it to regulate the power. The battery indicator appears on the display. This suggests that all nutrition comes from him. The UPS is not plugged into the outlet. The load appeared and the tension sank a little. Current strength is 500 milliamps. The current is measured on a homemade shunt, so it is not displayed as usual on the multimeter display. UPS output load 0 watt. UPS can now be compared to a portable power station or to a large power bank. You can connect a load to it and everything will be powered by batteries. I'll connect the computer power supply now. And look what happens, the uninterruptible power supply has turned off. The voltage from the battery assembly outputs has dropped. The BMS overload protection is tripped. UPS naturally does not turn on. In order for the board to work again, you need to disconnect the entire load, or connect the power so that it charges. I'll use the second option and take the network wire and connect it to the UPS. The voltmeter now shows normal voltage and the UPS turns on. The power plug indicator now lights up on the display. The UPS output load is just over 20 watts. It was because of this that the protection boards turned off. The problem here is this. It's not that the boards are weak and cannot deliver maximum current, but that the power supply has high-capacity capacitors at the input. And during connection to the UPS, the current was very large, although it was only a fraction of a second. That's why the overload protection worked on the BMS. It turns out that if you don't have electricity at home and you suddenly want to turn on the computer for 5 minutes, then you won't be able to do it. Now we will load the connected power supply with an electronic load. You can imagine that the computer is turned on. I'll make the power 230 watts. For UPS, this is certainly not the maximum power, but for our battery assembly, it is already the limit. I will now turn off the power from the UPS and all the load will be transferred to the batteries. This will be a simulation of the power being cut off at home. Now the plug light is on, and when I unplug the battery light comes on. Also look at the voltmeter and ammeter. The voltage on the batteries has increased and is dropping further, and the current is an impressive 28 amperes and is rising. Thanks to the current consumption, the voltage drop is compensated, and the power supplied by the UPS remains stable. If the voltage drops further, the current will naturally increase, and the boards are no longer designed for such a high current during prolonged operation. You can connect another load to a UPS that is disconnected from the network. For example, I'll take an ordinary light bulb. The tester will show the current consumed. With the light, the UPS turns on immediately. Power 53 watts. In general, I think that you can connect absolutely any load. The main thing is that during connection, there is not a large current due to which the boards can go into protection. These boards also have overheating protection. They are equipped with thermal sensors, located here. This is a small thermistor. In parallel, you can solder an external temperature sensor. For this, there are 2 holes nearby. Although the board has powerful field effect transistors installed, they still heat up. These 2 resistors also get very hot, and the voltage drop across them is measured to trigger the current protection. For some reason, the temperature for overheating protection is not written on AliExpress. At maximum power, my board got very hot and turned off. At first, I thought that the response temperature was set very low, and I decided to see at what temperature it triggers. I pressed the temperature sensor from my portable thermometer to the board with tape, and now you can find out the approximate temperature at which the protection operates. Since the sensor is metal, it can short-circuit everything, so I had to move it to the edge of the board. Here, I connected 1 battery of batteries, and the UPS is powered from it. When the board overheats, the UPS will shut down. I've just turned on this circuit and therefore the board temperature is still low. Then I sped up the video. In fact, what happens here is about 5 minutes. The load at the output of the uninterruptible power supply is slightly more than 110 watts. When the temperature reached about 72 degrees, everything shut down. This load was maximum for 1 BMS. The current was approximately 14 amperes. In theory, even in this mode, the board should have worked longer. But apparently, the developers didn't take something into account, and overheating still takes its toll. It turns out that for one board, a load of 100 watts is the maximum limit, and after 5 minutes of operation, it overheats greatly and turns off. Therefore, 2 boards and 8 batteries can hold a load of 200 watts for 5 minutes. But in my case, this load is very large. It seems to be taken with reserve. In fact, the power of the computer will not exceed 60 watts. In this mode, the boards hardly heat up, and if the battery capacity is sufficient, they can work for an entire hour. After assembling the battery and connecting it to the UPS, I did some testing, charged and discharged several times. I used a special device to measure the energy received and energy given out. The batteries are filled with 12 ampere hours each time. And during discharge, they deliver 11.8 ampere hours to the load. As expected, the result was good, but the discharge current here was about 5 amperes. And if the current is very high, then the boards will naturally heat up, and the efficiency of the entire circuit will decrease. Consequently, less useful energy will be supplied to the load. But given the powers used in this UPS, the difference will be small. As I already said, the computer power in my case will be only 60 watts. In this mode, UPS worked for 1 hour 50 minutes. The result exceeded all my expectations. Both boards barely warmed up, they were warm. So they are not in danger of overheating in the uninterruptible power supply case. In UPS, charging a new battery takes a very long time, more than a day. This is due to the fact that the charge current is limited to 0.6 amperes. If you want, of course, you can tinker with the circuit and make more current. But I don't have an urgent need for this, and so I left everything as it is. If you don't need such a lot of power, then one battery can be removed. The UPS will work fine on one. The operating time in this case will also be halved, and the maximum power will be approximately 100 watts. If you want to extend the operating time, you can also leave 8 batteries. In this case, you will need to solder 2 batteries in parallel to create a 4S2P assembly. If your UPS is much more powerful than mine and you want to receive more than 300 watts into the load, then you need to change the BMS board and take the appropriate power. The batteries can be left the same if the load does not exceed 350 watts. In other cases, I recommend installing more powerful batteries, which can deliver crazy current. In theory, you can leave these batteries, but under heavy load they will also heat up quite a bit. By the way, in the near future, I plan to remake an even more powerful UPS, power about 700 watts. It will use a 60 amp smart BMS with 15-hour batteries. If you want to see this video, write about it in the comments. Now you need to see how the new battery is inserted into the uninterruptible power supply compartment. Thanks to the layers of electrical tape, everything is inserted very tightly. The space in the battery compartment is very small, so if you put a lot of electrical tape on it, the battery may get stuck there. Scotch tape works better. It is very smooth and therefore the batteries slide inside easily. To make the battery move all the way to the left wall, the UPS can be shaken a little. To remove the batteries, you need to use these handles. The new battery turned out to be significantly smaller, both in height and in length. The weight also changed a lot. The lead-acid battery weighed 2,200 grams, and the new lithium iron phosphate assembly weighs 1,200 grams. The weight has become half as much, and the capacity is almost twice as large. The new battery will be installed in this uninterruptible power supply from APC, Model Pro 550, maximum output power 330 watt. If full power is ever needed, the BMS will have to be replaced with a new one. The battery compartment in a UPS case looks something like this. The lead-acid battery took up almost all of the space and kept securely there. The compartment was closed from below with a lid, and large stiffening ribs on the lid rested against the battery, fixing its position. The new battery takes up significantly less space. Although it holds, it is still not reliable enough. If the uninterruptible device stands still, then everything will be fine. But if you have to carry it somewhere, or move it, or if it accidentally falls on its side, then the battery may move. Therefore, all wires must be securely soldered and exposed parts insulated. Just in case, I covered the protection boards with a piece of PCB. It is foil, but fortunately only on one side. I made it up and pressed the clean side against the boards. Textilite lies on transistors and wires, so that small parts on the board should not break. At the joints, I used cambrics on both sides. Now there will definitely be no bare spots, and where the wires are connected to the UPS, you will need to wrap them with electrical tape. As you can see, upgrading UPS is not that difficult as long as you put in a little effort, but the result is worth it. Thanks to this improvement, the UPS will work for many more years, without losing power and replacing the battery with a new one. I put links to protection boards and batteries in the description. I recommend them for use in similar projects. Their cost is low, but the quality is decent. That's all for today. Subscribe to my channel if you haven't already. Ask questions in the comments if something is unclear to anyone, and goodbye.